everyone, my name is Aryan Uppin, currently pursuing Sri Venkateswara College of Engineering, Bengaluru, from the Department of Information Science and Engineering. So my USN is 1VE 23IS007. I'm going to cover the subject is data structure in language C. So subject code is BCS304. The topic I'm going to cover is Introduction to Static Hashing. So let's begin. The table of content are what is hashing, static hashing, how static hashing works, implementation of static hashing, advantages of static hashing, limitation of static hashing, and lastly we conclude. So let's begin. What is hashing? Hashing is a process of mapping a large data set that is key into a smaller fixed size table, hash table, using a mathematical function called a hash function. The purpose of hashing is to provide fast data insertion, retrieval, and deletion. The key benefits of hashing are to reduce the search time to almost constant time. For example, suppose you want to store the roll number of students in a system. Instead of searching all the entries one by one, using a hashing method to jump directly to the correct location. What is static hashing? The definition of the static hashing is the size of the hash table is fixed at the start and does not change throughout the program. Both the hash function and table size remain constant. Key features of static hashing are: first one, fixed size of the hash table, data retrieval and insertion are efficient, suitable for situations where the number and elements is known in advance. How the static hashing works. Static hashing is a method used in data structure where the hash table's size is fixed and a hash function maps keys to specific indices within that table. Components of static hashing. Static hashing has two main components. First one, hash table, and second one, hash function. What is hash table? A fixed size array used to store data. What is a hash function? A hash function that takes a key as input and generates an index for the table. The process of static hashing are: step 1, hash function calculation. The hash function maps a key to an index in the hash table. A simple hash function in static hashing is index is equal to key modulus of table size, where key is the input data to be stored, or table size is the fixed size of the hash table. For example, key is equal to 25, table size is equal to 10. By using the mathematical function, we can perform some operation to get the unique value to store that number into an index. That is, index is equal to 25 percentage modulus 10. We get the remainder as 5 to store the 25 value at the index of 5. Step 2, data insertion. After calculating the index, the key is stored in the hash table at the computed index. For example, for a hash table of size 10 and keys are 23, 45, 72. The key 23, by using the mathematical operation index is equal to 23 modulus 10. The answer is 3. By the remainder is 3. So store 23 at the index of 3. The resulting hash table is given below. Step 3, data retrieval. To store data, the same hash function is applied to the key. The resulting index is used to access the hash table. For example, to search for the key 45, apply the hash function. That is 45 modulus 10, we get the remainder as a 5. To check index 5 in the hash table, if it contains the 45, the key is found or else it is not found. Step 4. Collision handling. When two key maps to the same index, it results a collision. Static hashing use methods like chaining or open addressing to resolve collisions. Examples of collision are for key 23 and the 33 in a table of size 10. By using the mathematical operation like 23 modulus 10, we get the remainder as a 3. So 23 is stored at the index of 3. But in the same case, 33 modulus 10, we will get the same result as the 3 as a reminder. So 33 also maps to the index 3, but we cannot store the 33 at the index of 3 because of the 23 is stored already. It occurs the collision. Implementation of static hashing. Step 1. Define the hash table. Use a fixed size array at its hash table to store the data or the keys. Initialize all the slots to 0, indicating empty slots. For example, using main in, hashtag include stdio, hashtag define table size as 10, max table size is 10. By using the hash table array int hash table of table size is equal to array of 0, initializing all the slots to 0. Second step, hash function. A hash function calculates the index for a given key. Here we use the modulus operator. For a hash function, we use the modulus operator. For example, key is equal to 23 and table size is equal to 10. By using the mathematical formula index is equal to 23 modulus 10, we get the remainder as a 3. The key 23 will be stored at the index of 3. Insert function. Insert a key into a hash table. Calculate the index using the hash function. If the slot is already occupied, use linear probing to find the next available slot. Here is the given code. For example, insert 23. 23 mod 10, we get the result as a 3. Store 23 at the index 3. At the same time, insert 33. 33 modulus of 10, we get the same remainder as 3. It occurs the collision. Use linear probing to place it at the next slot, index 4. Step 4. Search function. Search for a key. Calculate the index using the hash function. Check if the key exists at the calculated index or nearby using a linear probing. For example, to search for 33, modulus 33, 33 modulus 10, we get the remainder as a 3, but index 3 has the value of 23. Check the next slot linear probing. Index 4 has 33 key found. By using the main function, demonstrate inserting and searching for keys. Int main, insert the key. Insert the key as 23, 45, 33, 72, and 12. Search for the key by using int result is equal to search of key. If result not equal to -1, print as a key percentage %d found at index of percentage %d key and the result, or else key not found. If the key is a 99, search is equal to search of key. If result not equal to -1, print key found at the index percentage %d key and the result, else key not found, and return 0. By using this, we can insert the input. For the input keys 23, 45, 33, 72, and the 12, the output will look like below as shown in the PPT. Insert key at 23 to get the index of 3. Insert key at 45 at the index of 5. Inserted key at 33 at the index of 4. Inserted key 72 at the index of 2. Inserted key at the 12 at the index of 12. 6. Key 33 found at the index 4. Key 99 not found. Advantage of static hashing. First one, fast data access. Static hashing offers almost constant time complexity for search, insert, and delete operation in the average case. For example, looking up a student ID in a hash table is much faster than scanning an entire array. Requires on simple implementation. It requires a hash function, a fixed size array, easy to implement in programming language like C, making it ideal for beginners. Third one, fixed memory usage. The size of the hash table is predefined and remains constant throughout the program. Advantage of fixed memory usage is avoids unexpected memory usage, making it suitable for memory constrained systems. Fourth one, efficient for small fixed database. The it works best when the number of key is small, a dataset size is known and advanced, save money and ensure fast performance. Fifth one, deterministic indexing. A good hash function ensures that a specific key always maps to the same index. Data retrieval is reliable and consistent. Limitation of static hashing are fixed size of the hash table. The size of the hash table is predefined and cannot be changed. If the data set grows beyond the size of the table, the new key cannot be accommodated. Second one, poor utilization of space. If the table is too large, many slots may remain unused, leading to wastage of memory. If the table is too small, it may cause frequent collisions. Third one, collisions. Multiple key can hash to the same index, leading to collision. The impact of the collision are resolving collisions by using chaining, open addressing, etc. to increase the complexity and affects the performance. Fourth one, insufficient for dynamic database. Static hashing does not support dynamic resizing. It results in it unsuitable for application where the dataset size changes frequently. Fifth one, dependence of hash function. Performance heavily depends on the quality of the hash function. A poorly designed hash function can cause uneven disturbance of keys, increase collisions, and reduce efficiency. Conclusion. Static hashing is a simple and efficient technique for storing and retrieving data when the size of the dataset is fixed and known in advance. It provides fast access to data with minimal computation and is easy to implement. However, it is limited by its fixed table size, potential for collision, and inability to handle dynamic dataset effectively. Thank you for watching.